In this video, I'll show you how to solve the ALEKS problem called Understanding Periodic Trends in Atomic Size. We're going to want to refer to a periodic table, so I have one handy for us right here. Now, the trend for atomic size, as we go down a column on the periodic table from top to bottom, the atoms get larger, and that makes sense because they have more protons, they have more electrons, things like that. As we go across a row on a periodic table, as we go from right to left, the atoms get larger. This is kind of confusing. Seems backwards, but as we go across the periodic table from left to right, we add more and more protons to the nucleus of the atom. Those additional protons cause the electrons on the outside of the atom to be pulled in tighter. So as we go across, the atoms actually start to shrink and get a little bit smaller due to the pull of those extra electrons. So this definitely feels like it's a backwards trend. Now this is the trend for atoms. For ions, a cation is smaller than its relative atom. So turning an atom into a cation causes it to get smaller. And anions are the other way around. When we turn an atom into an anion, it causes the anion to become larger. So with that information, we're going to rank these atoms and ions in order of decreasing size, which means we want to list the biggest one first. Let's start by just finding these elements on the periodic table. Here's sodium and here's cesium, and we also have the sodium ion. First thing we should do is just rank the sodium atom and the cesium atom with respect to each other. We can see that because cesium is lower on the periodic table, the cesium is going to be the largest, and sodium is going to be smaller than cesium. And then let's bring the sodium atom into this ranking. So we can't compare the size of a cation to anything other than its own atom. For example, we can't compare the sodium cation to the cesium atom. We can only compare the sodium ion to the sodium atom. It's a cation, and we know that cations get smaller than the relative atoms. So that tells us that the sodium cation is smaller than the sodium atom. So I'm just going to do this like this, and we have sodium cation as the smallest. Let's do the same thing here for our next set. Let's go find those guys on the periodic table. We have bromine and we have krypton. Now, to make sure that this problem is not too complicated, all of your elements are either going to be in the same column or they're going to be in the same row on the periodic table. Okay, so we're just going to start by comparing the atoms to each other. The bromine atom is on the left side of krypton, so that means that the bromine atom is larger than the krypton if we're just comparing those two. And now let's bring the bromide ion into the mix. We can only compare the bromide ion to the bromide atom. It is an anion, and that means that it is larger than its atom. So the bromide Br- ion is bigger than the atom. For the last set, I just have 3 atoms. Don't even have any ions there. So let's find those. I have oxygen, I have carbon, and I have boron. This one's pretty easy because I don't have to think about the size of the ions. Boron is furthest to the left, so it's the biggest, and then carbon, and then oxygen.